welcome to this second video on linear motion and forces. In this video we're going to be talking about acceleration. So the first thing I want to talk about is a definition for acceleration, and what acceleration can be defined as is how quickly the velocity of an object is changing. So for this we've actually got a formula we can use to calculate the acceleration. So before we look at that, we should just mention that there are two different accelerations. We've got acceleration where we're speeding up and deceleration where we're slowing down. So for the formula that we're going to be using, we need to know two velocities. So we need to know a start velocity and an end velocity, and we also need to know how long it takes to go from one velocity to another. So in our, for our formula, let's write it out. So we're going to have acceleration, which is given to us as A, is going to be equal to a final velocity, which I'm just going to put down as V, minus V naught, which is our initial velocity. So anytime we see something with a subscript 0, that is our initial value, in this case initial velocity. And I'm going to divide that by time minus initial time. Now we could just put it down as t if we just work out what the time taken is. In this case we've got, this is probably a little bit more accurate because we might not go from 0 to 10 seconds. If we're looking at a graph, we might go from, say, 20 seconds to 35 seconds, in which case the difference there is 15 seconds. Another way that this formula might get written is delta V over delta T. Now, what this delta sign is change in, or difference between. Alright, so we've got the difference between velocities and difference between times, or change in velocity divided by change in time. Now, if we've got velocity which is given to us in meters per second, and time given to us in seconds, our standard units for acceleration are going to be meters per second squared. So the way that that works out is we've got meters per second times by 1 over seconds. So when we multiply these together, we've got m over s squared, and that is just meters per second minus 2, or minus 2 squared. So that is our standard units. So again, we're looking at our standard units for meters per second and our standard units of time. Also, we will come across an acceleration due to gravity. So acceleration due to gravity, and for this we generally give it the symbol G, so G to be gravity, and we take this as approximately 9.81 meters per second squared, and that's just as a general thing all around the world. It does change slightly depending on where you are, but this is a close enough approximation that we just use it for all of our stuff. Alright, let's look at a bit of an example for this. So I'm just going to scroll up and scroll down, shall I say. Let's write out our formula. So A is going to be delta V over delta T, and let's look at an example here. If we've got a car accelerating from 20 meters per second, and I'm going to call this V naught, So let's make this a little bit better. Let's set it out a little bit better. So V naught is equal to 20 meters per second. And our final velocity is going to be 50 meters per second. And let's just say that the time in which it takes is going to be 5 seconds. Find out what the acceleration of this is. So let's plug it in. We've got our facts. Let's put in our formula, which we've already got here. Let's find it. So let's go, we're going to have 50 minus 20 divided by 5. In this case, that's going to be equal to 30 divided by 5. And, well, not 50, 5. And that is going to give us 6. 6 what? 6 meters per second squared. So that means for every second that passes, we're now doing an extra 6 meters per second faster than what we were doing in the previous second. So we found it, we fixed it. Don't forget your units. Alright, because it's a positive number, we can say that this is accelerating. Now, let's look at another example. In this case, I'm just going to write the formula again. Delta V over delta T. Alright, in this case, our V naught is going to be, let's go, 30 meters per second. And we're going to go to a complete stop, so 0 meters per second. Alright, and this is going to take us, let's say, let's pick a number, let's go over 12 seconds. Yeah, let's go 12 seconds, that'll work. Okay. So, what's our acceleration? Okay, so acceleration equals question mark. So, question mark there being what I want to find out. Alright, so let's plug these into our formula and see what we get. So, we've got our facts, now our formula, and we're going to go acceleration is going to be equal to 0, take 30, divided by 12. Now, 0 take 30 is going to be minus 30 divided by 12. So our acceleration here, and let's just grab our calculator. 30 minus divided by 12 gives us minus 2.5. So minus 2.5 meters per second squared. Now, because we've got a minus sign there, that means we're decelerating or slowing down. So deceler, not R. Decelerating, aka slowing down. Okay, so if you ever see a minus sign, minus means slowing down. A positive number means speeding up. And if it's 0, it's constant velocity. Neither speeding up nor slowing down. Alright, so if you are looking at a graph or looking through the question and it's going it's clearly saying what it's going from and to, and you can clearly see that it should be a positive number and you end up with a negative number. Go back and check your formula and check your calculations. Start thinking, is my answer actually reasonable? If you come up with a negative number but you are dead sure it's meant to be speeding up, go back and check. You might have put these two here round the wrong way. So you might have put your final velocity, your initial velocity first and your final velocity last, and which would make it a positive number here, though clearly it's meant to be decelerating. So that is it for this video. In the next video, I'm going to go through some different graphs. So we're going to look at velocity time graphs, we're going to look at distance time graphs, and what they mean. So thanks for watching. If you've got any feedback, please let me know, and we'll see you in the next video. Bye for now.